Hello, hello, hello everybody, and welcome back. Root Beer here with more of the 2011 Grade 11 Hypatia contest. So we are on question number 3 here. Positive integers x, y, and z form a Trenti triple if 3 times x is equal to 5 times y is equal to 2 times z. Okay. Determine the values of y and z in the Trenti triple 50yz. Okay. So, well, just take our definition for a stroll. That's usually how these questions go, and you'll find on Galois and Hypatias, some of the latter questions, especially question 4, will often introduce, here's some type of number, here's some definition, here's some type of shape, and this is how we define it. And you'll often get A, B, and C as you usually do. But A part will often very quickly just ease you into the definition. You know, compute this, list this, rearrange this, that sort of stuff. So even if you are not able to do, say, 4C, you should always at least attempt 4A. Same goes with 3A here. This is just rearrange the definition of a Trenti triple for the most part. So, if 50yz is a Trenti triple, then by definition I know 3 times 50 is equal to 5 times y is equal to 2 times z, correct? Yep, 3, 5, 2. Alright. So, just looking at, I mean, one of these we can actually calculate, 150. 150 has to be 5 times y, and 150 has to be 2 times z. But very quickly, just dividing there, we get 50 is equal to y, and 75 is equal to z. So 50, 30, and 75 is the triple. No other way about it. Okay. And notice that as soon as we know one of the numbers in a Trenti triple, the other two are sort of fixed. We have to get them. Okay? So there's never going to be a C part where they say list all possible Trenti triples that have, 50 as the starter, that sort of thing. But they could still have other Trenti triples all satisfy some sort of condition. Anyway, B part. Show that for every Trenti triple, x, y, and z, y must be divisible by 6. Okay, so why 6? Well, let's look at the definition here. There's not a whole lot to go on for a Trenti triple, but 3x has to be equal to 5y has to be equal to 2z. And the thing that catches my eye is 3, 2, and 5. They're all primes. Okay, and specifically 3 times 2 is 6. And the 3 and the 2 are the ones that don't have the y. So this question is based on, do you understand how prime numbers work in terms of divisibility? Okay, so for a Trenti triple, x, y, and z, we know that 3x is equal to 5y is equal to 2z. Okay, now, since 3x is equal to 5y, and they are all integers, right? Yeah, positive integers. Then we can see that 3 has to divide 5y. 3 divides 3x, and 3x is equal to 5y, so 3 has to divide 5y. But 3 is prime. So 3 divides 5, or 3 divides y. Right? We might have more, but it could divide. So the nice thing about primes, for people who don't know, if I've got a prime p and it divides a product AB, then either p divides A or p divides B. One of these statements must be true. Now, it could be that both of them are true. In this case, it's not. 3 does not divide 5. But the point is, this is a nice property that is shared by primes. Whereas, for example, 6, it divides 12, which is 3 times 4, but 6 doesn't divide 3, and 6 doesn't divide 4, so this doesn't work. But something like 5 divides 30, or that's not written as a product. A 5 divides, there's no way to write 30 that doesn't have a multiple of 5 somewhere in one of the factors. Okay, so that's a nice fact about prime numbers, and that's what we're using in this question. Okay, now we can see clearly 3 doesn't divide 5. I mean, that's just basic math. So 3 has to divide y. So 3 is a factor of y. Okay. Now, we could do the exact same argument and then get 2 has to divide y, and then sort of, well, if 2 and 3 are both factors, then their product's going to have to be a factor. But I'll show you another way to do it. So we can write y is 3 times some other number. Let's call it n. I don't know. Now, since 2z is equal to 5y, which is now equal to 15n, 2 has to divide 15 times n. 2 is prime. So 2 divides 15, which it doesn't, or 2 divides n. Clearly, 2 doesn't divide 15. It's an odd number. So 2 divides n. So we can write n as 2m. Therefore, y is 3 times 2 times m. And that tells me 6 divides y. We have written y as 6 times something. Okay. So there we go. We've proven that 6 divides y, and that's what they asked us to do. Okay. So the reason I chose to do it this way, to actually explicitly write out the 6, is to bring up another point. Primes are very special in that if I have a prime and it divides some number, and I have a different prime and it divides some number, then the product has to divide that number. This is not true even if you use the same prime. So if 2 divides n and 4 divides n, it is not true that their product divides it. Now you could say that if you have a divide n and b divide n, the lowest common multiple of a and b divides n. This is always true. But it just so happens that the lowest common multiple of 2 primes is their product. Okay? 2 different primes, by the way. And so we could have used this fact, and the lowest common multiple of 2 and 3 is 6, but I wanted to do it a different way, just so you can see how other approaches to the question. Anyway, now that was y must be divisible by 6. Now C part, show that for every 20 triple, the product x, y, z must be divisible by 900. Okay, so 900, a lot bigger. It was a little clear where the 6 was coming from, you know, the 2 and the 3. And we got 6 dividing y. But where does the 900 come from? Okay, and you could hem and haw and say, I don't know. If you get stuck ever on a question, go try another one. You know, you get stuck on 3, try 4. If that's not going to work, if you get stuck on 3, go back and make sure your write-ups for 1 and 2 are quite clear. Okay? And, you know, if you just can't do a question, that's okay. You just can't do a question. It's better to find that out when you're practicing so then you can learn more math and that doesn't happen in an actual contest. But never get stressed out just because you don't know how to answer a question. Just start writing down all available facts and maybe something will click, or you might at least get some part marks, even if you don't quite know what's going on. Now, for the 900, I'm thinking here, we know in B part y has to be divisible by 6, but why did we just do that with y? You know, we can't actually guarantee that x is going to be divisible by 6, but we can use the exact same reasoning. We'll have to write it up a bit. The reason we had y divide 6 because we had the 3 and the 2 here. Well, what if we chose to focus on x? X should be divisible by 5 times 2, or 10. Okay? And z here should be divisible by 3 times 5. So that's 15, a 10, and a 6. And I wouldn't be surprised if that multiplied out to be 900. In fact, 15 and 6 is 90 times another 10 is 900. So as soon as we understand where this 900 is coming from, suddenly it starts to pop into place. And usually for later questions, like a C part or a D part, go back and review what they made you do in A and B, because it's often set up. These questions are designed to sort of flow one part into another. Okay? So, by B part, we know 6 divides Y. Okay? Similarly, now I wouldn't just jump to 10 divides X, but similar to our reasoning, we'll use the same reasoning, we'll just go a little faster. So 3x is 5y is equal to 2z. So 3x is 5y, 3x is 2z. So 5 divides 3x, 2 divides 3x. Therefore, 5 divides x, 2 divides x. See, I'm writing down the same reasoning, so it's clear to the marker, but I'm not spending so much time writing all the sentences that I did last time. I'm also going to jump to, this implies that 10 divides x, fairly quickly. Okay? This part is not the hard part of the question. Okay? We're establishing the same fact just with x and with z here. Okay? Now, if you're worried about it, if you're a stickler, you get stuck on question 4, you want to come back and polish this, by all means, add the same sentences, add the same sort of reasoning, polish your reasoning. You want to use the LCM, lowest common multiple argument, go right ahead. But similarly, we have 2z is equal to 3x, and 2z is equal to 5y. So 3 divides 2z, 5 divides 2z. I'm not going to really mention the prime argument because I don't need to keep mentioning that. It's the same theme over and over again. So 15 divides z. Okay. So we can do something like, we can find A, B, and C so that x is equal to 10a, y is equal to 6b, and z is equal to 15c. And for our product, x, y, z is going to be 10 times 6 times 15 times a, b, c. And that's 900 a, b, c. And that tells me that 900 divides x, y, and z. A, b, and c, I mean, you could mention that they have to be positive integers. I don't really think it's necessary because everything we're doing in this question is positive integers. But there it is. So that's 3C right there. And if you're worried about it, add more sentences, add more explanation. Basically just duplicate what you did in B part to establish that 10 divides X and 15 divides Z. But I would say as long as you make the same points, I mean the key points are you set these equations equal, you've got, you focus just on the prime, and the prime can't divide 3, so there you go, and then you combine it at the end. I think that's those are the major themes, so that's all I reproduce here. Okay, so I'm going to flip the page in anticipation of our next and last question, and that is question number 4 on the 2011 Hypatia. I will see you guys for that video next time.